Hi. Today we're going to look at our next section in Unit 1 called Use Congruent Segments. Not quite as much vocabulary as the first section, but we do have a few things to look at. Our learning target is we are going to learn something called the segment addition postulate, and in fact we're going to add segments using that postulate. So a couple of definitions here. We've got postulate / axiom. Postulate is something you'll see a little bit more often than axiom. And then the other one is theorem. So basically these two ideas in geometry or math in general is they're basically rules that we function with in math. So a postulate is a rule that we accept without proof. So it's just sort of, it's closer to a definition, things like that, a little bit more basic. Theorems, though, are rules we accept with proof. So geometry is a lot about proof. So probably the most famous example that you've heard of is the Pythagorean theorem. So the Pythagorean theorem, a squared plus b squared equals c squared, is a theorem that was proven through an idea that we will learn this year. It was proven under a certain set of criteria to basically say that this particular theorem works all the time. Okay, so we will learn tons of theorems this year, tons of postulates, and we'll talk about what this idea of proof is. One of the first postulates here is the ruler postulate. Okay, and it's, like I said, postulates are a little bit more basic. So this postulate says that the distance between any 2 points is the absolute value of the difference of the coordinates. Okay, so from a really basic perspective, let's say that A, if this is a number line, let's say that A is sitting at 0 and B is sitting at 1. And if I were to ask you, well, how far apart are those numbers? You would tell me 1. Well, the ruler postulate says, well, you should be able to take the absolute value of the difference of these two numbers. Okay, so if I were to take A minus B and take the absolute value of it, it's going to be the same as B minus A. So if I were to do 0 minus 1, I get -1. Well, the absolute value is 1. 1 minus 0 is 1. Absolute value is 1. Now we're dealing with length. Okay, so we cannot have a negative length. All right, so that's why we have to take the absolute value to get that amount. I'm also going to add, I'm just going to add the word length in here. Okay, so a lot of times when we are trying to find the distance of something, a lot of times they'll say, what is the length? So they kind of get used interchangeably. Okay, segment addition postulate. This is the basic postulate wording that you would find in geometry textbooks. If point B is between A and C, then AB plus BC equals AC. Okay, so let me kind of break this down a little bit. So if I have a point between two other points, so let's put point A right here, and let's put point C over here. So point A and point C, we're going to put on a segment. Now, if it says that it's between, that means it is on that segment. So that means B is collinear with A and C. Okay, so that means B is somewhere on this segment. Doesn't have to be halfway, it just has to be somewhere. Like I wouldn't be able to put B up here or down here because the phrase is between in geometry means it lies on the segment. Now, when there are no bars above this, I'm gonna put here length. And I'm gonna put here no bar. So instead of me reading segment AB plus segment BC equals segment AC, when I see that there's no bar above it, I'm going to think or say length. So the length of AB plus the length of BC equals AC. So this is a really simple postulate. If I were to take the length of AB and add it to the length of BC, well, that would give me the whole length. So from a super basic perspective, if the length of AB is 1 and the length of BC is 4, Well, the length from A over to C is 5. Okay, I can simply add those together. Okay, or the opposite. Let's say, I didn't know the 4. If I knew the whole thing was 5 and that piece was 1, well, then I could subtract them and get to 4. All right, so that's the segment addition postulate. We use it quite a bit in geometry. Okay, before we jump to examples, I want to go through just a little bit more notation. The word congruent may or may not be a familiar word. So the word congruent means the same. And so congruent segments are segments that have the same length. Okay, so length refers to numbers. Congruence, though, refers to the names of the segments. So what that means is if AB is the same length as CD, then we would say that the names of those shapes are congruent, but the lengths are equal to each other. Okay, so just a couple of other things. The congruent symbol looks like this. Looks like an equal sign with kind of a little squiggly above it. This tick mark here tells me that they're the same length. And I have it again over here, tick marks. Now, I don't know how long they are, but I know they're the same length. So no bar above it. Remember, we would say the length of AB equals the length of CD. With a bar above it, segment AB is congruent to segment CD. Now, the lengths deal with numbers. So this could be like 5 equals 5, but this is the name of something. So we would say that segment names or geometric names are congruent. So we'll talk a lot more about that going forward. Okay, let's find some lengths here. Find each length. Notice there's no bar above it. So what's the length of XY? What's the length of XZ? So I want to see how far apart are X and Y. Now, you can count on the number line, all right? You can certainly look at that and be like, well, if this is at 1.5 and this is at 5, you could even kind of count. I could say, well, this is 1, 2, 3.5 units long. So the length of XY is 3.5. I'm going to go back and show you again with the absolute value idea, because sometimes it's not quite as easy. Sometimes they're really big numbers, or maybe they're decimals or fractions. So I'm just going to say that the absolute value, it doesn't matter which number we put first. So I'm going to put 1.5 minus 5. Okay, and so the absolute value, if I continue on that, is negative 3.5, but when I'm taking the absolute value, we have to have a positive length. Okay, so either method is fine. I'm not saying you have to show your work like this, but you have to get to that. So I want you to pause and do letter B. So we should have 4.5. Okay, you could do the absolute value if you wanted to. You could do negative 3 minus 1.5, and we're still going to get 4.5. Okay, let's continue on. Okay, let's look at some segment addition postulate questions in a variety of difficulty, okay, because we can get into some complicated algebra with these problems. All right, M is between N and O, okay, so that tells me that M is on the same segment as N and O. Find the length of NO, okay, so I want to find this length. So I know this little section is 17, 3x minus 5, and the whole thing. So on this first example, I want to write the segment addition postulate out as an equation. Okay, so I'm going to say that NM, the length of NM plus MO is equal to the whole thing, NO. All right, and then from there we can just substitute into the equation. So I could say 17 plus 3x minus 5 equals 5x plus 2. Okay, and from there we solve. So I would combine these together. So I would do 17 minus 5. So I would have 12 plus 3x equals 5x plus 2. Okay, and then we can do it in 2 steps or 1. You could do it a couple ways. I'm gonna move my 3x over. So if I take away 3x, that would leave me with 12 equals 2x plus 2. And so then I'm going to have to move my 2 over, take away 2. So that gives me 10 equals 2x. And when I divide off, I get x equals 5. Okay, so a lot of times in geometry, notice it doesn't say find x, it says find NO. So I need to come up here and find the expression for NO, and I'm going to substitute in 5 for x. So I'm going to have to do 5 times 5 plus 2. So that would be 25, 26, 27. So NO equals 27. And there's no unit on here, so we'll just leave it as 27. Or you could say 27 units if you want. Okay, I'm going to pause this video here because the last 2 examples are going to be a little bit longer. So come back to the next video and take a look at 3 and 4. If you want to start 3 and 4, you can, but let me separate this out into another video.